Hi, I'm Abraham Hopkins for Green Building Pro, and today we're with Manny Gonzalez and Don Neff checking out the ABC House. That's A for affordable, B for buildable, and C for certifiable, not for one, but 6 of the major green certifications in the US. And this also happens to be a net zero home. This is a super ambitious project. So guys, tell us why the ABC House.
The idea is that somebody could build this net zero energy house and have it certified anywhere in the country, whether it's a rural location or some infill piece someplace in the south or a semi-urban area, or part of California where we've been hugging trees for quite a few years now.
So are you a tree hugger, Manny?
I have to be. That's really where the industry is going, and yeah, I know that's some of your other questions, but I think it certainly is where the home building industry is going, and I think the intent here is to show that it's not really difficult to build this, and the net zero energy is truly that, trying not to be paying out electric bills, utility bills, even water bills and sewer payments to the extent you can, and it causes us to have to think a little differently in the way we build, but most people think of a net zero energy because of the ads that you hear on the radio and on TV as putting photovoltaics up on the roof and getting free energy that you sell back. But the simplest place to start is just in a good, solid design of the home and making it energy efficient without having to put those things on.
That's correct too. Just to come back then to the different programs we're going to talk about and then how we get there. Let's talk local. In California, there's a couple primary green building programs. Of course, Cal Green, which is the new California building code, and that was adopted January 1st, 2011. So clearly this home needs to comply with that. And there's different standards of greenness, so to speak, that one can build it to, design and build it to. So Cal Green Code is one of the first ones. Related to that, though, is the Build It Green program. Now, Build It Green was a private nonprofit sponsored green building program some years back, and they've gotten a lot of traction in Northern and Southern California. And so we thought that would be important to consider too. Now, those two programs are broad in their encompassing a variety of green building components, and they're both within the state of California. Now, stepping beyond that, we have two very energy-focused green building programs, and that would be the California Advanced Home Program, which is sponsored by the investor-owned utilities, such as Southern California Edison, Pacific Gas Electric, etc. And that is, as I say, narrowly focused on energy conservation issues. Now, and that's California alone. Now, you also have the Energy Star program, which is an energy-focused program, but that's national in scope. So that would be your second pair of green building programs, so to speak, that we're focusing on.
Okay.
So then the last two green building programs are national in scope, combining a lot of green building elements, not just energy. And one is LEED for Homes, and that's sponsored by the U.S. Green Building Council. You've probably heard of that one. And then the NAHB, or National Association of Home Builders, they've got a green building program as well. So both of those are national in their focus with a multitude of green building elements. So there you have 6 different programs, and I'd like to characterize them as 3 different pairs. The first pair is California only with a broad focus. And then 2 that are energy intensive, 1 local, 1 national, and then the 2 national green building programs. So that kind of sets the stage for the certification processes that we're going to take the house through and to confirm that it can be basically built and certified anywhere in the country.
I think one of the things to point out, Don, is that LEED certification is probably the most common name that people recognize in outside of the industry. In the industry, they recognize Energy Star and some of the other ones just as well, especially here in California.
Yes.
But I think the curious thing about LEED is that it doesn't necessarily have to do with energy. You can get a LEED certification without a whole lot of energy features in a house by doing other sustainable things. So I think that's important to identify, and that's why having it be able to be certified under all 6 of these categories runs the gamut from energy efficiency to sustainability to using recycled materials and quite a few different things that are good in the home building industry in general and not necessarily certifiable. And I recently had my first LEED Platinum building certified in Playa Vista, and it didn't have any photovoltaics. And so it's not difficult to do a LEED Platinum if you just do a good design, and you can avoid some of those extra costs like photovoltaics.
Yeah, that's a great point. In fact, coming back to something else you mentioned earlier, people think of green building homes as those with solar panels on the roof. Well, it's a whole lot more to it than that. But curiously enough, several years ago at the Pacific Coast Builders Conference, PCBC, in San Francisco, and we go there and exhibit every year. Wonderful conference to attend and network at. But one year, it seemed like everybody and their brother had solar panels they're advertising. This was the green building movement. But in fact, that's just one really small component of what it takes to build green. And one starts with, as Manny suggested, the design, the orientation. The building envelope is so important, how it's insulated, whether you got efficient framing techniques in it. What about the water system? Because quite frankly, there's a lot of embedded energy in water. A lot of people don't think about this, but let's say you're transporting water up and down the state, or it takes energy through pumps to do that. So there's a huge amount of embedded energy in that water. So to the extent that we can conserve water with the efficient plumbing designs, we conserve energy also.
You pointed out that a LEED home doesn't have to have energy savings, and an ENERGY STAR home doesn't have to have sustainability points. But what you did is cool. You hit all 6 certifications and built a home that by any standards is truly green. So what have you discovered? What have you learned in the process?
Probably the most critical thing is to build the right house and build it smartly.
Yes.
And it goes just from the programming to build a house that's the right size. We went back and forth on 1- and 2-story homes, and the square footage and the cost that we had to deliver for Edison brought us into about 1,700 square feet. And to do 1,700 square feet, it's more expensive to build a 2-story than a 1-story. So the single-story plan was selected. Doing things like having whole dimensions on the framing to try to make the rooms 12 feet instead of 10.9. Sounds like it would cost you more, but in the long run, you get a more efficient house. You use just about the same amount of framing. And so smart thinking and smart design actually gets you a long ways there. And I think Don will tell you that when it comes to the certifications, you can get a good portion of the way there before you start touching anything with utilities or any other elements that have to do with energy. But good sustainable design, and I think one of the biggest things that we did on the house was go from the conventional framing of 2x4 studs at 16 on center to 2x6s at 24. Everybody in this country, for the most part, builds out of 2x4s. But going to 2x6, we go from R11 to R19. Mm-hmm. You're almost increasing your energy by your energy efficiency in the walls by twice the amount. You actually build with less lumber if you do it properly with just single studs on the corner, the 2 corner posts.
So you incorporated advanced framing into it.
That's in there. Mm-hmm. And the single story obviously makes it a little bit easier to do. But you start with an envelope that is a more efficient envelope than what you typically build, and we're already a long ways towards certification on any one of those 6 platforms, especially relative to what the typical home would be.
I would venture to say that this could be characterized to be a vintage home, California bungalow style. And when I say vintage, you think back to the olden days, the golden days of home building in California, in Southern California particularly, where California bungalows were so popular, and the configuration that was used at that time included detached garages. Coincidentally, detached garages aren't healthy for the house because you don't have fumes from garden maintenance equipment or your car itself that can come into the home. You have a long eaves that can be oriented properly given the solar orientation of the house to the south. And the advanced framing elements that Manny mentioned. Now, combined with this, of course, is the building envelope itself, the insulation in that building envelope. And right now, the team is considering alternative insulation strategies for that. And not only does one need to build a tight building envelope, but properly insulated. So what you end up with then is very little air movement through the walls or the roof assembly. And when you minimize that air movement, you're minimizing energy losses. So very important. Now, in the scheme of things, there are a couple of tests that one needs to do in the certification process. And just to give you kind of an overview, soup to nuts view of that, you start with the pre-construction elements. That would be kind of the design review component of the certification process. Then you go into the construction side of this, and so you're out there. The certifiers need to be out there, and we'll be out there a couple different times, critical stages during the construction process, at rough stage and at final stage. And then there's the post-construction phase of certification. That's where you're actually testing the performance of the home. So in that regard, you want to do a blower door and duct blast test, and that measures, the blower door really measures how tight the building envelope is. Tongue in cheek, a couple of my HERS Raider friends say a home is not tight enough until when you close the front door, the toilet will flush by itself. Okay? Now that is a very tight house, all right? But that said, a house that's tight, you won't lose any energy through the building envelope. All right. Now there's a couple other strategies that we'll talk about, but then the blower door is one of two tests I mentioned. The second test is the duct blasting. Now ducts historically and unfortunately have been very leaky in California housing production. And up until October 2006, the acceptable duct leakage rate was 22%. What that means is 1/5 of your AC flow, your air-conditioned flow, was outside into the world. All right. Well, that's very inefficient. After October 2006, the acceptable duct leakage was reduced to 6%. Okay. So that means you need to test these ducts to make sure they're tight and you're not going to lose any conditioned air, which is energy, in effect. So those two elements, the building envelope and the ducts themselves, go into saving a lot of energy.
I think Don raises a good point when he talks about code changing, because I think when we're looking at 2020, it's the code that's going to tell us what to do. And I think we're gradually getting there, and I actually think we're getting there faster than we thought, because I think that you find city councils and you find state government that's thinking it's a good thing to sell a good store, to talk about being sustainable, and putting out initiatives that give them credit with the voters for being a sustainable government group. So I think you're going to start seeing a lot more of it coming online quickly, and we have to adapt. Every time California puts out a new building code, we've got to change the way we design. But I think, especially here in California, you're almost there if you comply with the building code on a lot of these rating systems.
Yes, in fact, 2020, the California Energy Commission will be requiring zero-net energy home construction. And you think of what that means. That's just over 8 years from now. And you think about where production housing world is today. Well, I think we can get there. The challenge, however, is new construction within the state of California only represents 1 or 2% of the total housing stock. And we still have 98, 99% of the housing stock that was built to old standards.
Sure.
And really needs to be retrofit.
I want to go back to one other thing that Don was mentioning when he was talking about the bungalow style, because we discussed the architecture character of this building for a while at the beginning of the process. You go back, some of my very first sketches were pretty contemporary, but then I was mentioning that there's surveys out there that say that home buyers prefer traditional style of architecture. There's only 11% of home buyers that want a contemporary design. I think that's going to switch going forward as younger kids start getting into the home buying industry, because I think they're more inclined to like the trendy contemporary things. I know the young architects in my firm do. But we chose the bungalow for a number of reasons. One is that that style of architecture has a very simple roof. So you'll see that the roof form is just a simple front to back pitch. Don was mentioning the garage, some cases they're detached, but in this case it's attached because of the size of the lot. But it's attached, and its roof actually sheds the opposite direction, but a simple pitch as well with gable ends. There's a couple of reasons. One is it's easier to frame, less material, less hips. It looks fine from a craftsman standpoint. But that house would allow us, with those 4 orientations of roof, to put photovoltaics on it, if we in fact do, in any direction, depending on the site. So you can orient the house properly to the street, but still have the photovoltaics going in the correct direction without having to reframe the roof. So there's a lot of little things that we thought through. One other thing I should throw in when you're talking about the tight envelope, and this, I actually learned a lot doing this, and one of the things that I learned was that if you heal the truss, especially if you're trying to get more insulation in the roof, if you heal the truss as it gets to the eave line, you're actually able to get that larger bad insulation all the way out to the end, and that eave line is where a lot of the air infiltration will come if you don't have that tight joint between the wall and the ceiling. So by having it be a little bit taller and being able to roll that bat all the way out to the end, which the people in construction will do if it's not too difficult, allows you to have a complete energy, a better energy envelope by doing that. Because you can still run the numbers. An architect can still say put R30 in the attic, but if you can't get it in the end,
you can't get it in the end.
That
yeah,
really do you any good.
Do you want to explain what you mean by healing?
By healing the truss?
Yes.
When you get to the end of a truss, usually the top cord sits on the bottom cord like that, so when you're trying to put the insulation in, you're going to hit that joint and you won't be able to get it in that last foot or so. But by healing it, there's actually a vertical piece that comes up at the end, so the top goes a little bit more like this. And in the case of a lot of our house, we actually have a porch or patio, so the roof extends out and it's automatically healed to a couple of feet and you can get it in there with no problem. So the selection of a lot of things in design, starting even with the style of architecture, can make it easier for people to obtain the certification, and in the other two of the ABCs, make it affordable and make it buildable as well.
So
just to drill in for a second, if you're healing the truss like that, how do you do the eave vents, or do you vent the roof in a different way?
We don't actually have to vent the roof because we're putting a hard ceiling on. We will put vents in there because we're going to have high and low, but you only need to vent it. You can get it on the gable ends. That's one of the other nice things about having that gable is you can get the high ventilation up there.
Okay.
But it can be a tight ceiling or a tight roof if you would like.
Great.
Yeah, so I was going to come back to the insulation discussion again. And by using the efficient framing practices and the raised trusses, so to speak, with the heels, you're able to get more depth of insulation at those locations that are sensitive. It's where the thermal bridging will occur. Thermal bridging, that's a concept where you've got inside temperatures that go through the framing members to the outside without proper insulation. That'll occur at the eave line. That'll occur at the corner of the building, wherever you got too much wood framing in effect. And so with the efficient framing practices, 2x6 is 24 and center, you minimize that. With the heel trusses, you minimize that also. So you get better and more uniform thickness of insulation all the way around your building envelope.
And those are just better design practices all around. And when we were doing this house, we were looking at a lot of different things. And one that was certainly different than what I've done in production housing for the last 20 years, especially here in California, is to put the FAU in a closet, do a vertical FAU. Because I think most builders around here and in a lot of parts of the country put it in the attic. That's where it goes. And
So
John Morton,
you're moving it indoors, so it's in an air-conditioned environment. Is that the advantage?
That's one of the advantages, is that it's in there. The other advantage is that you don't have to go in and out of that envelope with your ducts. It's entirely in that space. And then the third advantage, when you look at the floor plan, is that closet is in the hall, right in the center of our house. So the runs for any ducts that we have are absolutely as short as you can make them, and they're directs in every corner, or in every case. When you look at a typical house, you'd be coming up, down, around, on corners, and every elbow you get less efficient. So we're really able to just go down the hallway and have direct runs, a fewer amount of elbows. It does take up a little space that might be valuable in 1,700 square feet, but I think when you look at the floor plan, the house for 1,700 square feet lives just fine, and you don't miss that 3x3 closet that's in there. And there's actually, not to get off track, but there's plenty of storage in other areas, and we've looked at that, and I think that's one of the other nice features of this, is the house is designed for tomorrow's buyer who goes to Costco or Walmart and buys in bulk.
So the moral of that story is that you want all your ducts within the conditioned space.
You want all your ducks in one row.
That's right.
And it also sounds like having all those ducts the same length with the same number of minimized bins makes the system really easy to balance out, so you don't wind up with a hot room and a cold room, which I'm sure many people have experienced.
So think about this. Think about that 98% of the existing housing stock in California is built to the old standards, which might have FAUs in the attic area with ducts that are maybe R4.2 insulation throughout, and the attic area is so blasting hot in the summertime, maybe 140 degrees or so, and you're trying to cool down, air conditioning the air up there and move it, and those are leaky ducts. That's the fate of the bulk of the housing stock in California.
And at the other time, when it's cold up there and you're trying to heat, you're up there in the coldest part, or one of the coldest parts of the house.
It's crazy.
It's counterintuitive, and really a lot of the things that we've done here are just thinking common sense, and it goes back to some of these practices that you used to put the FAU in the hall.
Yeah, absolutely.
And we went away from it probably because it's less expensive to do, but when you look at the overall package that you're delivering and the ability by bringing it inside to downsize it now, make it more efficient, I think you're actually the trade-off, and all these ones we've looked at, every one of these trade-offs, while it may be a little more expensive to put in 2x6s, the energy efficiency lets you downsize, and the trade-offs, when you get down to that bottom line of $300,000, I think the things that cause it to go up slightly in cost are more than offset by the things that you can save. And certainly in the life cycle cost of the house, there'll be a huge savings.
You know, a good analogy to think through about this particular ABC home is that of the cars that are hybrid these days. Now, you think, well, the hybrid car may cost a little more right now, current generation, but they're way less expensive to operate, right? Because they have a different kind of power production system. And so with the green building homes, generally high performance homes, they may cost a little bit more at the margin, first time costs, but the operating costs are way lower than that. So it's kind of the same kind of trade-off one needs to think about. And in the context of doing a high performance home properly with a efficient framing, properly insulated, over insulated if need be, you can, as Manny's suggesting, downsize the HVAC system. In fact, there's a great book here. This is really the Bible for energy-free housing construction. If any of the members of the audience want to learn more about Zero Net Energy Building, this is a great book for that. It's written by Ann Edminster. It's entitled Energy-Free Homes for a Small Planet, and this truly is the Bible for zero net energy construction. In fact, I was talking about earlier, though, on the roof and the PV element of a green building program, is that unfortunately, because of the leaky ducts we have now, the inefficient framing practices, the poorly executed insulation in these existing homes, what we find is that the studies in this book have indicated that we would need 3 times the roof area of your average home covered with PV panels to produce the energy necessary to basically address all the energy that house would need. Now, that's the inefficiencies. If, on the other hand, we would start from scratch and we have a tight building envelope, tight ducts, properly insulated, efficient framing, we could downsize the amount of PVs required, something to be more normal, more affordable.
There's just general concepts that are coming into home building that are going to be driven by the cost of energy, by the way people think, by the next generation of home buyer. And we've actually found that there's a community that we did in South Jordan, Utah, that is a contemporary style. It is 75% energy net zero. So it's almost there. It's got photovoltaics, and a lot of the first buyers are what we call guilty hippies. They're people that are in their 50s or 60s and moving out, but they were the ones that drove the SUVs for the last 10 or 12 years, and now they've got the Prius pulling up in the driveway and living the green lifestyle. So I think that there is a movement there. I don't necessarily think it's all the global warming that's driving it, but just trying to save money, trying to be less of a burden on the environment and build a more efficient house. And I think, we were talking about this home being 1,700 square feet. There certainly is a movement that way. Don and I were talking before this about the new communities that we've got, and the size of homes are getting smaller. That LEED Platinum one I mentioned in Playa Vista, we redesigned a previously approved community and downsized the units by about 30%, because that's where the market's going. You don't need that big house anymore, and I think that people are starting to understand that, and I think we're going to be building more efficiently, thinking a little bit more about it, and the buyers are going to react to that. And if we ever...
We're getting down to the end here. I don't want to kill all of our time. Maybe we can do what I'd call a hot seat, and we just do rapid fire questions. I shoot you some questions, you fire back with an answer as clear and tight as you can do it, and we just spend the next few minutes just wrapping everything up.
Absolutely.
Okay, so with the ABC house, we talked about how it's super insulated, how it's designed well, the roof exposure. What other elements helped it qualify for these 6 different certifications?
Well, we had to do some things to have it qualify for specific ones, and one of them with LEED and air quality was doing what Don said. I don't think I've done a production house that had an attached garage that didn't have a door from the garage into the laundry room or a hallway of some sort. This house, you actually do not walk through the laundry room. You go out through the porch and in. It's covered, it's protected from weather, but it does allow for better air quality inside, and I think that's one of the things that is important. So it's actually a cost savings. You're going to have the man door on the garage. Now you don't have it. It gives you more storage space in the laundry room, and that's the way people used to live. You used to walk from your garage through the backyard into your laundry porch. So there are things like that we've done that I think you won't find in production houses, but maybe going forward people won't object to that, and you'll see some things like that happening that allow you to be on the LEED side. The Energy Star really is picking out those appliances and fixtures that comply with Energy Star and materials, but those help you in all the other ones. So I think it's some of the things like recycled material. It's probably going more toward the LEED aspect to get certified for that, because we're going to be green and comply with just about every other one. So I think it's some of those things that we're bringing into play that are important. And they have to do with site design and where you are.
Right. Orientation to the south, where the solar, the sun's pattern.
And gray water too is another thing that's an interesting topic, because you have to fight with local jurisdictions. I think some of the sustainable features of what people want to try to do are still up in the air with building codes and local officials and city councils and planning commissions that haven't adopted the gray water aspect yet. And I think that's an important thing for sustainable design to take into account and for jurisdictions to look into, because I think it is a good practice and it does save that water.
And to the extent that we use energy modeling to replicate the performance of the home after construction, the use of a mechanical engineer, really plumbing engineer on the team, I think could go a long way toward minimizing the water wastage in this particular home. And that's something else that I have discussions about on a side note. But to the extent you have large and long runs of water piping for potable water through the house, you're wasting a lot of water and energy. There's a device called a demand pump. May well be considered here. A demand pump basically pushes cold water from the hot water side back into the cold water side until it reaches a certain temperature, so you're not running that water down the drain. And that's a little device that is picking up some traction out there in the marketplace, and it's very effective.
Great. Now, Don, here's a question for you. Besides the end user, for the ABC house, what's the biggest threat to it not getting different certifications when it's actually being built in the field?
One more time now? One more time, please?
Yeah, sorry. When we're actually building the ABC house, during construction, what are the biggest threats to having a building meet its potential in terms of energy savings?
I would say the biggest challenge really is who will be the trades constructing the home, because what we're talking about here are practices that are not standard accepted in the trades today. They're pushing out a little beyond that. So what we're going to be doing is looking for higher performance on the part of the trades to deliver the quality in construction practices. Really, if you're going to build a high-performance home, green building, you really got to pay attention, closer attention to quality. So, for example, as part of the Energy Star program, they've got this thing called Thermal Bypass Checklist and QII. QII stands for Quality Insulation Installation. So you've got an inspection exercise over the insulators to make sure there's no, compressed bats or voids in the insulation of that building envelope. Unfortunately, there hasn't been a lot of comprehensive training with the trades on green building or high performance building principles. And so that's lacking. That could have an effect as we're building this home. That remains to be seen.
But I think one of the things that's interesting in the industry as a whole, there are a lot of home builders that are embracing the green building, and they're getting value out of that sale. And I think they're going to start training their construction crews as to how important it is to get that LEED certification or that green build certification, whatever it is that they're going for, because I think it is starting to sell homes. There is a market for those.
Coincidentally, we're working with several key building companies that are exclusively doing urban infill projects, smaller, they're high performance building projects, and they're selling like hotcakes.
For hitting the net zero, you've showed us all these energy savings, but how do we get from having a really tight, efficient home to being an absolute net zero home?
Well, that we're going to have to use the photovoltaics and generate some energy somehow. So we're planning on putting some of those on the roof. We're trying to limit the amount that we can, and that's why the real energy efficient home and the energy efficient envelope is critical. I think trying to make sure that the mechanical system and the other systems in the house don't use too much energy to have to be offset by the photovoltaics is key to this. And I think it even goes back to what Don's saying, which is some user tendencies in the way that they take care of the house. The net zero energy is at the end of the year, you're looking at what you spent and what you used. It's not something that you can run. You can run a model on it, but if you can be efficient living in your house, two different families could come up with two different results in the same house with the way they live.
It's true. So part of that is to monitor performance after the home is built and it's being occupied.
Don, Manny, it's been a pleasure. Thanks for spending time with us and telling us about the ABC home. We're very excited to follow up with you and see what kind of performance we get in the real world.